Приглашается Ричард Харнес с опытом из Соединенных Штатов Америки. Тема доклада звучит как «Модернизация до последнего, выбор оптимальных устройств для защиты дикой природы». Please.
All right, so that's going to be a tough act to follow. Thanks a lot, Andrew. So if you were going to give an award at this conference from coming the farthest distance, we definitely would be in the running for that. So we have a 12-hour time difference. So I don't know where I am right now. And I think JD would probably actually get it because he lives a couple blocks west of me. So I think actually technically he went further. But if you were going to give an award for the most boring title for a presentation, I think I would get it. All right, so we're going to talk about retrofitting the last, selecting optimal wildlife protection products. I promise you the presentation would be better than the title. Okay, first of all, a lot of my work deals with animal contacts. So I know the subject we've been talking about is raptor electrocutions, but this issue goes beyond just raptors. And so the types of things that we're talking about when we're doing remediation for raptors, you're also going to be helping other animals as well. So for example, in Central and South America, monkey electrocutions are a huge problem. And there are lots of other birds that get electrocuted as well, as you can see with this American white ibis on the right. And you also see how quickly those events occur. All right, so why do we care about all this? Well, obviously as conservationists, we have our own drivers, our own passion for birds. It's just right out of the gates, we know that this shouldn't happen. But you can also make a good business case about why this shouldn't happen. And that's because these types of events are impacting the utility grid as well, and also impacting their customers, impacting their equipment, and there are costs associated with those. So we do quite a bit of work with EPRI, or the Electric Power Research Institute. And back in the 90s, they reached out to their members and asked them what sorts of issues were they having with animals getting into the grid. And so they got a pretty detailed survey went out to their members, and they got 43 responses from their utilities. And in essence, what we see is around 9% of all known outage causes are caused by animals, one kind of animal or another. And when we take a look at those numbers of outages, we also know that about another 10% of all outages are unknown. So we feel pretty comfortable that this 10% number is pretty good. And so these types of events are, first of all, an opportunity for a utility company to improve their reliability because we can fix these problems. And it does come with a severe cost as well. There's some ancillary issues associated with this, which are really rising to the top in the United States, and maybe it will in other areas as well. But with climate change, we're ending up with areas that are now susceptible to massive wildfires. And every time an animal gets into the electrical grid, it's a thermal event, right? And if that animal creates a thermal event that starts a wildfire, then the risk to the utility company can possibly go way up. So there's some secondary issues as well. Public relations. When a monkey gets in your substation and takes out the entire country, right? So the entire country has no power for 15 minutes. You're going to be in the news, and it's not going to be favorable. We talked a little bit about the legal liability. And again, so there are some legal structures in places in different countries where utilities can be fined for the illegal taking of birds, which could include electrocutions and in some cases bird collisions. And so if those laws are enforced, you can end up with some significant fines, like this utility in the US that was fined $10.5 million for electrocuting eagles. Okay, regarding the scope, we don't really know what the scope of this is, but if you've been attending these presentations this week, you know that it's happening too often. So again, because it's preventable, the number is less important than, that we should be doing something to make the power systems more robust while also saving birds. Right, so let's talk about mitigation. And we're going to talk about mitigation also as it plays into different material types. Okay, so to begin with, what's our goal? Well, our goal is we want to minimize the possibility of an animal electrocution or related outage. So in other words, we just want it to stop. And typically what we're going to do when we have existing infrastructure is we're going to put some sort of product on, like these products that are up here. And by the way, if you want any of these products, please take them because they're not going back on the plane with me. We want these products to be readily adopted by staff. So Andrew just talked about, hey, they had something that was fail-safe, it was easy, you just put a couple of bolts up on it, you're done with that structure, you're on to the next. It has to be something that the utility crews are very comfortable using and they like using it. Because if the linemen don't like it, you're going to have a lot of problems getting something implemented on your system. So it's always a good idea to pull them into the mix when you're coming up with a retrofitting plan. And the topic of this presentation, we want to have a long service life. We don't want these things to go up and then 4 years later, 5 years later, we're replacing them. Right, so let's talk about different material types and how it comes into play. So in North America, slide on the side, the left-hand side of the slide, this is a very common configuration made out of wood. Now, wood's not a perfect insulator, but it's pretty good. And so the issues that we tend to have in North America is phase to phase. So an animal like an eagle getting between these two different phase wires. All right, so that's in essence the issue. As you move to other places that use grounded pylons and arms, your issues are shifting now to be more of a phase to ground problem. So here's an example of that type of pole in India. So there's several different contact points on there. All right, so what do we do? Well, there's two different things that we can do. One is we change the design standards. And I'm not a proponent of saying that you have to pick one material over the other. I'm really a proponent of saying it's an engineering problem. You need to tell the engineers, this is the size of animal that we have. You need to come up with a way that these animals can't make a phase to phase or phase to ground contact. So in the case of the US, again, up on the left, this is the approach that we might take with new construction to prevent eagles from being electrocuted. Right, so basically we use a longer arm. Now they can't go between the phases. Right, when you're using grounded pylons and arms, again, there's many different ways to do this, but for new construction, you might use suspended insulators, you might extend the pole top, pin up on the top with a cap. Again, they're all engineering decisions and solutions that can be implemented. So build in your clearances. And if you want a good reference for this, this document came out recently, this IUCN document, and it covers a lot of different options of different things that you can do. So I would recommend you get a copy of this. If you want a training module, the WWF, USAID, and CLLC recently developed an online training module. It's about an hour long on both collisions and electrocutions. That's quite beneficial. Okay, so where are we landing though now? If we can't build it, well, let's say if we're dealing with existing infrastructure and we need to retrofit, right? Well, you're going to end up in this area here with most likely some kind of insulation. You're going to put some aftermarket product onto your utility system. Caution, Raptor protection measures using insulation are not designed to protect linemen. Okay, so these types of products are meant to deal with incidental wildlife contact. So don't be thinking about it as if it's safer contact for linemen. Okay, so we're going to go back to this same issue again. So we've got our wood pole, and we decide we want to do something with that one. And we say, hey, look, there's all these different conductor guards that are available. Some of them are down here. We have to pick one of those. Which one do we pick? And then once we do that, we put it on the center phase. We take that center phase out of play, go on to the next pole. If you're dealing with concrete poles and metal cross arms, as Andrew just illustrated, there's a variety of different things you could do there. But again, you could land in this arena and say, yep, I want to use some kind of conductor guard. I got to pick the one that I want. But in this case, you need 3 of them versus 1 because you're concerned about all these phase to ground contacts. A point that I want to make that we haven't talked about too much here is that regardless of whether it's a new line or you are doing retrofitting, you are going to have equipment on those poles. And it's been my experience that it's these types of poles that have a lot of jumpering going on. They're sort of the odd out configuration on the landscape, especially in very rural areas, are the ones that are of the highest risk to birds because there's a lot of complicated things going on. And the point I want to make is that when you're retrofitting, you need to pay attention to this as well. So pieces of equipment like this have to be covered. So this is a transformer unit. This unit needs a bushing cover on all 3 of the bushings. These are surge arresters. The tops of these arresters are energized. They also need arrestor caps. All of the conductor needs to be covered, leaving no gaps. Yeah. Now, when we talk about using these types of products, we have to realize that distribution structures are going to be on the landscape for decades. You know, they're going to be there longer than those of us in this room are doing this kind of work, especially me. I'm not going to be around 50 years. And so we need to make sure that we're picking pieces of aftermarket products that first will withstand surface electrical stresses. So we don't want electricity to find its way across these products and create a whole new separate set of problems for the utility. They have to be installed on equipment that can operate at 140 C. So there's some pretty high temperatures. So we don't want to put plastics or polymers on here that are going to melt after a while. And in the step, we're really going to be concerned about things like ultraviolet exposure as well. If you don't pick a good quality product over time, ultraviolet will degrade it as well. And this is an example of that kind of degradation. So we have jumper wire that was covered at one point, now it's degraded and it's become ineffective. Wind and extreme weather. We want our products to stay on regardless of what's going on out there with the wind. Hot and cold and extremes. We don't want devices coming off due to contraction and expansion. So again, you've spent all this time and money to go out there to put a product on, and now it's laying on the ground. And then sometimes there can be some unusual cases where you're concerned about surface contaminants. So for instance, if you're putting products on in areas where there's salt contamination, or as Andrew was talking about, they had concerns about sand. So that could be a concern as well for different covers. Okay, the Electric Power Research Institute has a compendium of animal cause outage prevention products. And in that, it notes that there are over 347 products today to mitigate power line electrocution issues. Okay, so now here's the challenge. First challenge is finding what you need. And then once you find it, you may find that there are actually multiple products out there. So for a bushing cover, so the bushing cover is probably the most common item that's used in the utility industry to mitigate animal outages. When you go and you look at the different bushing covers out there, you'll find there's 35 of them, and they're made from a variety of different materials. And in some cases, you won't even know what the material is because the vendor won't tell you. They'll just say it's proprietary. So you have these similar looking products that have very different formulations, very different performance and cost. So how do you sort it out? All right, so again, our goal is we want something that works. And we want something that the utility people like. And JD is going to wow you with his presentation after mine on 1 and 2, but we want it to have a long service life. Okay, so we need to pull the engineering team in to figure out what are their concerns in their region and come up with a list. So I would say probably on everybody's list is going to be having something that's UV stable, non-tracking, those are non-starters. If you're in a contaminated area, you might want something to be hydrophobic. Maybe fire resistance is important to you, et cetera. All right, so how in the world do you sort all this out? Well, I would guide you to go to this document, which is the IEEE guide for testing really wildlife protective devices on overhead power distribution systems rated up to 38 kV. It's IEEE 1656. And what this document does is it lays out for you a sequence of tests that you should perform on animal products in order to allow you to gauge effectiveness from product 1 to product 2 to product 3. And I'm going to run through basically what this testing entails, kind of an abbreviated view of that. So the sequential format is you do baseline dielectric testing, and then you put some environmental stress to it. What do I mean by that? Something like ultraviolet, and you subject it to that stress, and then you turn around again and you repeat what you did in A, and you see how it performs. And if those products pass, it means those individual samples show ongoing dielectric effectiveness, because that's what the utility cares about. They want the power to keep flowing. So this is the flow of the sequence of tests. There'll be a quiz later. Primary test number 1 is the wet withstand test. And in essence, what this is you're taking a device, you're putting some water on it, you're subjecting it to voltage, and then you're making sure that the voltage doesn't go through that material. So in other words, you want it to work. So is this material going to withstand that stress at that voltage? So it's very simple. This is the process. So you record what that value is. It has to achieve at least 8,600 in the previous 8.6 kilovolts in the previous slide. And then the next test that you run to is this wet power frequency flashover test. This has nothing to do with whether or not it's effective. What the utility wants to know in this test is that, is this device here going to compromise the electrical system in terms of the insulators that are out there keeping the electricity from finding its pathway to ground? So in essence, what they do here is you run a test where you take this to failure. So you have a baseline value when you know that if you subject this to a certain voltage, that it reaches a critical point and exceeds it, and you end up with a flashover. And then you do the same thing with a product. And what you want to see is that that product isn't significantly impacting that particular test. So this is the fun test. So you're actually bringing something to failure, measuring it. So then after you've done that, you've got your baseline, you can start doing things like running an ultraviolet aging. So in this test, what you're doing is you are taking the sample of whatever product that you have, you're putting it in a chamber, and you're running it for 8 hours with UV exposure at 60 C, followed by 4 hours of condensation exposure at 50 C. And you record the condition of these samples before and after, which is mainly descriptive. But then guess what you do? You take these and you subject them to those first two tests that we just did. Okay, and then you measure to see, well, if you're exposing this to UV, what sort of impact is it having? Is it significant or is it minimal? If you're in a high contamination area, you might do the same thing with something like salt fogging as well. And then there can be some just other tests that IEEE recommends that you do if you are in an area where you're concerned about flammability. The IEEE document outlines how you would do that and how you would record those results. There's also a section in there on retention testing. So again, you want to make sure that these devices stay on. So if you have a large budget, you might go to a place like NASA that has a great wind tunnel and do your wind testing in there to see if these products will stay on. Most of the time, you're going to do the redneck testing. So I don't know if you know the word redneck, but put your device in the back of a pickup truck and measure the speed. All right, so this all seems very, very complicated, and in fact it is, because I'm hitting it at a very superficial level. But the good news is that because utilities are now relying on the IEEE standards, vendors, companies that make these products, are now actually doing the testing for you. So for instance, this is a Powerline Sentry product, and you can see that they have the results of all the IEEE testing right here. So the idea being that if you were interested in using this product right here, you could take a look at their results, and then you could look at another company's product, and then you could compare those as well and make an informed decision. So in conclusion, this is a global issue. I think fortunately solutions exist, and we're getting more and more products, and they're becoming more and more robust. Obviously, this is what we want to do. We want to get ahead of this right out of the gates. But if we have to retrofit, we're going to need to use insulation with products that meet standards. Durability is an issue. I would suggest you look at the 1656. And then another piece of this is make sure you're just going out there and monitoring the effectiveness yourself. And with that, I'd like to acknowledge the Altai project, EPRI, IEEE, NRECA, Caddis Enterprises, Powerline Sentry, TE Connectivity. Thank you.